Having seen composition of functions, we are now going to decompose the function. We're asked to express the function in the form f composed with g, where g of x is equal to the cube root of x over 1 plus x. Remember that f composed with g of x is equal to f of g of x. And we tend to think of things in terms of an outside function and an inside function. G is the inside function, f is the outside function, and when I look at the structure of the cube root of this rational function inside, I'm thinking the outside function f of x is equal to the cube root of x, and the inside function g of x is equal to x over 1 plus x. And you can see if you put that rational function inside of f, then you end up with g of x as given. Sometimes there are multiple ways to break down a composition, to decompose a composition function. Usually what you want to look for is like a big outside function and then an inner function. Sometimes there are 3 functions that are composed. Like for instance, if this was x squared and x squared, then I'd be looking at, well, inside of all of that is maybe an h of x that looks like x squared. The reasons for wanting to be able to do this will become evident down the road in this course, but for now we're asked to decompose, and that's what it looks like. Now we'll look at an application that involves a composition of functions. An airplane is flying at a speed of 350 miles an hour at an altitude of 1 mile and passes directly over a radar station at time t equals 0. So we've got a radar station and we've got a plane that passes 1 mile directly overhead, and I'll go ahead and assume it's 1 mile above the ground. It's not an assumption, an altitude of 1 mile. So 1 mile there, and the plane is flying at 350 miles per hour. Express the horizontal distance d that the plane has flown as a function of t since flying over the radar station. So d as a function of t here, since this plane is flying at 350 miles per hour, and we know the distance is equal to rate times time, this should be 350 t. So that is part A. So there's our d. Now we're to express the distance s between the plane and the radar station as a function of t. That's going to be a hypotenuse. So there's s. Now here we have a right triangle, and one side we know is 1 mile, one side is d, and the hypotenuse is s. And so using the Pythagorean theorem, we have that s as a function of d is equal to the square root of d squared plus 1, or d squared plus 1 squared, right? Now we're to use composition to express s as a function of t. So folks, we have an expression for d, that's d of t is 350t, and then we have an expression for s that depends on d. And so using composition, I'm basically going to substitute s of d of t, right, there's the composition, is equal to the square root of 350t, that thing squared, plus 1. The result here, s as a function of t, is the square root of 122,500 t squared plus 1. So there's our A, our B, and our C.